So this is your V naught equal to A naught times of Vi plus A1 times of Vi. So just put here, and this will be passes through what? Band pass filter. And after passing through the band pass filter, you will get the AM signal. Okay. So just passes through a band pass filter. So just put here, and after putting this value, you will get the output. This V naught equal to, this is A naught times of M of t plus AC into cos of omega ct plus A1 times of M of t plus AC into cos of omega ct whole square. Just explain here. This is A naught M of t plus AC cos of omega ct plus A1 M square t plus AC square cos square omega ct plus twice of M of t into AC cos of omega ct. Cos of omega ct. Got it? Now, what will happen actually here? Okay, my dear friends, M square t is the DC signals. Okay, DC power. So it will be blocked by your band pass filter. This is your M of t without carrier signal. It will also blocked by the band pass filter. And output of the band pass filter is, output of band pass filter will be, this is A naught into AC cos of omega ct plus, this is also, this is the DC powers. So this will be also the cancel out by the band pass filter, and this is your 2 times of A1 into M of t into AC cos of omega ct. So just write down, this can be right here. This is A naught AC common out. So the A naught AC 1 plus twice of A1 by A naught into M of t into cos of omega ct. And this output of band pass filter, this is called AM signal. Now, this A naught AC can be right here AC dash. AC dash. So your equation becomes AM equal to AC dash 1 plus twice of A1 by A naught into M of t cos of omega ct. So just equate with the original. This is 1 plus K into M of t into cos of omega ct. So here K amplitude sensitivity is, amplitude sensitivity. What's the amplitude sensitivity? This is twice of A1 by A naught. By using what? A square law modulator. Got it, my dear friends? Is it clear? AC square into cos square omega ct. This can be right here. This can be right here. AC square by 2, 1 plus cos of twice of omega ct. And this will be blocked by the blocking capacitor, and this will be blocked by using your band pass filter. So only this component which passes through the band pass filter, and this component which passes through the band pass filter. So amplitude sensitivity is twice of A1 by A naught. So what's the beta? Modulation index is what? K into Am. If M of t equal to Am cos omega M2. So modulation index beta is Km into Am. K into Am. This is the question of GATE. 2 marks. The question is, write down, for the following square law modulator, V naught equal to Vi plus 0.1 times of Vi square. V naught equal to Vi plus 0.1 times of Vi square. And pass band of band pass filter will be from 800 hertz to 1200 hertz. Will be from 800 hertz to 1200 hertz. Find all parameters of resulting AM. That is बीटा निकालिए, टोटल पावर निकालिए, कैरियर पावर निकालिए, बैंडविड्थ निकालिए, टोटल साइड बैंड पावर निकालिए. और ये दिया हुआ आपको, दिस इज एम ऑफ टी 20 cos 200 pi t. This is summation 20 cos 2000 pi t. It is your Vi. This is square law device. This is V naught. This is band pass filter. And by band pass filter having the band of 800 hertz to 1200 hertz. And this is AM signal. And write AM signal. This is not the 20, this is 2. This is 2 cos 200 pi t. Okay, my dear, how you can write? A1 is what? 0.1. A naught is what? 1. So what's the AM signal? Resulting AM signal is what? This is A naught AC 1 plus twice of A1 by A naught into M of t. This is cos of omega ct. So just write down A naught is 1 and AC is what? AC is 20. So this is 21 plus twice of A1. This is A1 is 0.1 upon 1 into M of t is twice of cos 200 pi t, and this is cos of 2000 pi t. This is AM signal. So the equation of AM signal becomes what, my dear friends? This is 20 into 1 plus 0.4. This is cos of 200 pi t is into cos of 2000 pi t. Got it? Now you can write the each and every one parameters. Is it clear, my dear friends? Got it? Please write each and every one. Clear है कि नहीं? देखो डेरिवेशन से कितना आसान हो गया, इतना बड़ा क्वेश्चंस को आपने एक लाइन में बना दिया है कि नहीं? अब यहाँ पर सारा कुछ मिल गया आपको, कैरियर पावर डायरेक्ट निकाल सकते हैं आप. कैरियर पावर क्या हो जाएगा, पीसी AC स्क्वायर बाई 2, दिस इज 20 स्क्वायर डिवाइडेड बाई 2, दिस इज 200 वाट। बीटा कितना, 0.4। ओके, एफिशिएंसी कितना हो जाएगा, बीटा स्क्वायर अपॉन 2 प्लस बीटा स्क्वायर, जस्ट बताइए 0.4 स्क्वायर 2 प्लस 0.4 स्क्वायर इंटू 100%। व्हाट द एफिशिएंसी, एफिशिएंसी बताइए तो कितना आ रहा है, एफिशिएंसी बता होगा कितना आ रहा है। सॉल्व करके बताइए जल्दी फटाफट, क्विक, कैलकुलेटर लेके बैठा करो। सेवन 7.4%, ओके, दिस इज 7.4%, ओके। चलिए, ये हो गया आपका एफिशिएंसी। चलिए, टोटल पावर आप निकाल सकते हैं, PT इक्वल टू PC 1 प्लस बीटा स्क्वायर बाई 2, दिस इज 200, 1 प्लस 0.4 स्क्वायर डिवाइडेड बाई 2। व्हाट्स द टोटल पावर PT, yes please, what's the total power PT, जल्दी बताओ। थ्री सिक्सटी, ओके, 360 वाट। टोटल साइडमेंट पावर PT minus PC, this is 160 watt. Got it? Bandwidth is what? Twice of FM, that is 2 pi FM equal to 200 pi. Twice of FM is 200. This is 200 hertz. चलिए, क्लियर है सबको? नेक्स्ट देखो, स्विचिंग मॉड्यूलेटर। Switching modulator, it means generation of AM by using your switching modulator. This is M of T device, just a summation of plus, this is carrier signal C of T. Now this is your VI and it is passing through the switching device. And this is V naught, that passes through the band pass filter, and this is your AM signal. So AC into cos of omega C. So what's the VI, my dear friends? This is VI equal to M of T plus C of T. Okay. So this is M of T plus AC into cos of omega CT. Now, what is the switching device? So switching device is nothing but diode. Here switching, we use the diode circuits. What we use? Diode circuit. Okay. And basically, as you know that if diode is your ideal diodes, this is anode potential, this is cathode potentials. So if VAC is positive, diode is what? diode is short circuited. If Vs is negative, diode is open circuited. Diode is open circuited. Okay, my dear friends. So if carrier signal is positive, then VAC is positive, then diode is short circuited, then V0 becomes VI. So for case 1, if C of t is positive, then V0 equal to what? VI. Why? Because diode is forward biased. Case 2, if C of t is negative, diode is reverse biased, this is open circuited, and this is open circuited, so V0 equal to what? 0. Is it clear, my dear friends? Is it clear, my dear friends? Please write each and every one. So when CT is positive, then diode is forward biased, so V0 equal to what? VI. But if CT is negative, then V0 becomes what? 0. Okay. So what will happen actually output? So output is not the fixed output. Output will be varied from 0 to VI. So just write down. Here output is not fixed. Here output is not fixed. It switches between 0 to VI. It switches between 0 to VI. So to plot its spectrum, we consider a periodic waveforms. We consider a periodic waveform GPT. Because output is not fixed, that means to plot the spectrum, we take a periodic waveform. So this is your periodic waveform. This is your periodic waveform. This is 0 volt, this is 1 volt. Let's say this is 1 upon twice of FC. So this is 1 upon 4 FC. This is 1 by 4 FC. And this is your T equal to 1 by FC. This is your periodic waveform. So what will happen actually output? So output will be what? VI into GPT. And GPT is a periodic waveform. And as you know that if any periodic signal, and if you want to convert into the sinusoidal signal, we take what? Fourier series. So GPT is a periodic signal. So just convert GPT into your what? Sinusoidal signals. So to take the sinusoidal signals, we have to consider the periodic waveforms, and periodic waveform can be converted into the sinusoidal signal by using your Fourier series. So GPT can be right here. This is A0 plus summation running from n equal to 1 to infinity an into cos of n omega t plus bn into sine of n omega t. And as you know that this is even function, so for the even function bn equal to what? 0. So GPT is nothing but this is A0 plus summation running from n equal to 1 to infinity an cos of n omega t. Got it, my dear friends? Is it clear? Please write each and everyone. Clear or not? इसलिए बोले थे आपको कि सिग्नल सिस्टम इज द मैथमेटिकल टूल्स ऑफ सिग्नल एंड सिस्टम. आप समझ में आया? सॉरी, सिग्नल सिस्टम इज द मैथमेटिकल टूल्स ऑफ कम्युनिकेशन सिस्टम. आप समझ में आया? सिग्नल के कितने यूज कर रहे हैं हम कम्युनिकेशन में. इज इट क्लियर माय डियर फ्रेंड्स? प्लीज राइट ईच एंड एवरीवन. Why we take this periodic signal? To plot is a spectrum, because a spectrum is not fixed. That's why to plot it's a spectrum, we take the periodic waveforms. Clear? Please write. Why bn 0? वाह, this is your event signal ना. Event signal का bn क्या होता है? 0 होता है ना. सिग्नल सिस्टम किए हो ना मानिक? सिग्नल सिस्टम याद करो, पढ़ाया हूं. याद आया? नहीं याद आया? चलिए अब ए नॉट निकालिए, ए एन निकालिए इसका, एंड मल्टीप्लाई करके हम इसका स्पेक्ट्रम ड्रॉ करेंगे. सो ए नॉट इक्वल टू व्हाट? बताइए, ए नॉट क्या हो जाएगा सर? 1/t minus 1/4 fc to 1/4 fc 1 into dt. T equal to what? 1/fc. So thus just write here fc into 1/2 of fc. So this is your 1/2. So a naught equal to 1/2. Now what's the n? N is 2/t, 0 to t, f of t, cos of n omega t into dt. So just 2/t. So this is twice of 1/fc. This is minus 1/4 fc to 1/4 fc 1 into cos of 2 pi n into fct into dt. Just integrate it, and after the integration you will get an equal to twice of n pi sine n pi by 2. This is your an. Can you integrate it? Right, please. Can you integrate it? I have already discussed in your Fourier series. So GPT can be right here 1/2 plus summation of running from n equal to 1 to infinity 2 by n pi sine n pi by 2 into cos of 2 pi n fct. So V naught equal to what? Vi into GPT. So this is m of t plus ac cos of omega ct into GPT. So GPT can be right here 1/2 plus 2 by pi, n का वैल्यू 1 रखिए, 2 by pi cos of 2 pi fct minus 2/3 pi cos of 2 pi into 3 fct plus 2/5 pi cos of 2 pi into 5 fc इंटू टी, इस तरह से बढ़ता चला जाएगा। व्हाट इज माय डियर फ्रेंड्स? एंड इस सिग्नल को आप किससे पास करना है? बैंड पास फिल्टर से। और बैंड पास फिल्टर से आपको मिलेगा क्या? एएम सिग्नल। अब बैंड पास फिल्टर करेगा क्या? ये डीसी सिग्नल को ब्लॉक करेगा, ये पास करेगा एंड हायर फ्रीक्वेंसी को ब्लॉक कर देगा। सो आउटपुट ऑफ द बैंड पास फिल्टर, मैं डायरेक्ट लिख रहा हूं, आउटपुट ऑफ बैंड पास फिल्टर, दिस इज इक्वल टू, ये आएगा आपका सर 2 by pi m of t cos of omega ct plus AC by 2 cos of omega ct। यहां पर AC by 2 कॉमन ले लीजिए, ये बन जाएगा 1 प्लस 4 by pi AC m of t, दिस इज cos of omega ct। दिस इज बैंड पास फिल्टर आउटपुट। और यही क्या है? एएम सिग्नल है। AC by 2 को मान लिया मैंने AC डैश। सो एएम टी इक्वल टू AC dash 1 plus 4 by pi AC m of t cos of omega ct। So amplitude sensitivity is what? 4 by pi AC. For what case? Switching modulator case. This is your amplitude sensitivity. This is very, very important. Sometimes directly ask the question, what is the amplitude sensitivity in the case of what? The case of switching modulator, you can just directly put here. So this is your generation of AM signal. So this is the AM signals, AM equations of by using your switching modulators. So my dear friends, modulation is done at what? Transmitter end. And demodulation is what? Demodulation is done at what point? Receiver end. Receiver end. Okay. So write down demodulation of AM signals. Demodulation of AM signals. Write some points. Okay. To extract the original message signal, to extract the original message signal, we have done demodulation process. To extract the original message signal, we have done the demodulation process at the receiver end. At the receiver end. And there are various methods which is used for the demodulation of AM signal. There are various methods which is used to demodulation of AM signal, and such as first, a square law demodulator, second envelope detector, third synchronous detector. Synchronous detector. But a square law and envelope detector is preferred for beta less than equal to 1. It is preferred for beta less than equal to 1. And it is preferred for any value of beta. That is under modulation, critical modulation, and over modulations. But a square law demodulator and envelope detector is valid for only beta less than equal to 1. Now, out of these three, mostly we use the envelope detector for the demodulation process. Mostly we use. Okay, my dear friends, is it clear? Is it clear? Please write each and every one. So first one is your square law demodulator. Now demodulator, it means what? You have input is what? AM signal. So you have to given the input is what? AM signal. So this input is AM signal. This AM signal is just passes through the square law device. And at the output side, this is your low pass filter. And you will get the M of t message signals. This is the low pass filter. The AM signal is what? AC into 1 plus K into M of t cos of omega ct. Okay. Now, a square law device. So this is, let's say, Vi, and this is V0. So V0 will be what? A0 times of Vi plus A1 times of Vi square. So the V0 can be right here. A0 times of AC into 1 plus K into M of t cos of omega ct plus A1 times of Vi square. So this is AC into cos of omega ct plus AC into K into M of t cos of omega ct ka whole square. Got it, my dear friends? Is it clear? Is it clear? Please write each and everyone. Clear or not? Now, after this output, it is passes through low pass filter. A low pass filter is what? Integrator. Low pass filter is nothing but integrator. So this V0 can be right here. A0 into AC cos of omega ct plus AC into K into M of t cos of omega ct and plus A1 into, okay, A1 into, this can be right here, AC square AC square cos square omega ct plus K square M square t into AC square cos square omega ct plus twice of K AC square M of t cos square omega ct, है ना? अलग अलग कर दिए. Now it is passes through the integrator, low pass filter. जब इसको इंटीग्रेटर से पास करोगे तो इसका इंटीग्रेशन का वैल्यू क्या होगा? 0. इसका इंटीग्रेशन का भी वैल्यू क्या हो जाएगा 0, तो ये ब्लॉक हो जाएगा, ये ब्लॉक हो जाएगा। अब जब इसको पास करोगे आप तो इसको क्या लिखोगे, cos स्क्वायर ओमेगा सी टी को 1 प्लस cos 2 ओमेगा सी टी बाई 2 लिखोगे। इसको भी लिखोगे 1 प्लस cos 2 ओमेगा सी टी बाई 2 लिखोगे, और इसको भी लिखोगे 1 प्लस cos 2 ओमेगा सी टी बाई 2 लिखोगे, राइट। सो द आउटपुट ऑफ लो पास फिल्टर बन जाएगा आपका, आउटपुट ऑफ लो पास फिल्टर इज नथिंग बट इक्वल टू, इसको क्या लिखेंगे आप यहाँ पे लिखेंगे ना, इसको लिखेंगे 1 प्लस 1 बाई 2 1 प्लस कॉस ऑफ 2 ओमेगा सी टी, एंड 2 ओमेगा सी टी का एवरेज वैल्यू 0। ऐसे ही इसको ब्लॉक करोगे 1 बाई 2 1 प्लस कॉस ऑफ 2 ओमेगा सी टी, 2 ओमेगा सी टी का एवरेज वैल्यू 0। ऐसे इसका करोगे 1 बाई 2 1 प्लस कॉस ऑफ 2 ओमेगा सी टी, एंड 2 ओमेगा सी टी वाला कंपोनेंट 0 हो जाएगा, सिर्फ बचेगा क्या, a1 ac स्क्वायर बाई 2 वाला कंपोनेंट, जिसको ब्लॉकिंग कैपेसिटर क्या करेगा, ब्लॉक कर देगा, राइट, कैरियर सिग्नल्स को। सो लो पास फिल्टर आउटपुट विल बी, डायरेक्टली मैं लिख रहा हूं यहाँ पे, ये बनेगा आपका a1 इंटू ए सी स्क्वायर के स्क्वायर एम स्क्वायर टी, a1 इंटू के स्क्वायर एम स्क्वायर ए सी स्क्वायर डिवाइडेड बाई 2, और ब्लॉकिंग इसको तो इसका एवरेज वैल्यू 0 कर देगा, डिवाइडेड बाई 2 बचेगा, प्लस ये वाला कंपोनेंट बचेगा कितना, a1 इंटू डिवाइडेड बाई 2 करोगे, 2 से 2 कैंसिल आउट हो जाएगा, a1 इंटू ए सी स्क्वायर के इंटू एम ऑफ टी, ये बचेगा लो पास फिल्टर का आउटपुट, क्लियर। तो इसको मान लेंगे हम एक्सपेक्टेड सिग्नल, दिस इज योर एक्सपेक्टेड सिग्नल, ओके, एंड दिस इज योर ए सी स्क्वायर के स्क्वायर है, so this is your unexpected signal, and unexpected signal is considered as noise. In the communication system, unexpected signal is considered as what, noise, my dear friends. Is it clear? Please write each and everyone, clear or not? So this is your signal and this is your noise, okay, this is your signal and this is your noise. So just find the S by N ratio and log in with the third ID. Just find S by N ratio. Log in with the third ID.